All right, so this video is going to be chatting with you guys about subspaces. So subspaces, you want to think of them as a specific characteristic within a vector space. So a vector space has a defined addition rule and multiplication rule. So that vector space is defined. So like polynomials, we add polynomials this way. We multiply by a scalar this way with polynomials, okay? So then a subspace is defined within that vector space if the zero vector is in H, and H is inside of V. So we'll just kind of draw like here's your vector space, and then H is like a subset, okay, of it. So you have your addition and multiplication definition set, and then we want to look at just a subset of that vector space. So if you have two things in H and you add them and they are also in H, subspace met. If you have a vector in H and you multiply it by C and it's still in H by whatever the definition of that is, subspace. But a subspace must have all three of these properties. So let's talk about a little more about polynomials. So let's let P be all polynomials with real coefficients, okay, and just normal operations defined by functions. So addition and scalar multiplication is what you have always known. Then polynomials is a subspace for all real valued functions defined on R. So what does that mean? If you add any two polynomials, you get a polynomial. The 0.00 is there, right? And if you multiply a number times a function or times a polynomial, you get another polynomial. So it is a subspace by definition. Okay. Also, each n greater than 0 is a subspace of the polynomials, okay, because they have, so yes, I just walked you through this, okay? So that's how this works with polynomials. Let's look at this one. So this example from the text says that the vector space R2 is not a subspace of R3. R2 isn't even really a subset of R3 because we're in R2, not in R3. So let's say the vectors in R3 have 3 entries, okay, whereas 2 only have 2. But let's let H be in R3 with ST and 0, okay? Now, be careful because I know that this might look and act like R2, but because it has the 0 vector or the 0 spot here, it makes it R3. You can't say that it is equivalent to ST, okay, because it does still need that third spot, right? Vectors can only be equivalent if they have the same number of elements, so we can't have that. All right, so show that H is a subspace of R3. So is the 0 vector there? Yes. Number 1, S equals 0, T, goodness gracious, T equals 0. Possible such that H equals 0, okay, is here. If I add two vectors, so let's let U be ST0 and V be XY 0. If I add U plus V, I get something S plus X, T plus Y, and then 0. Yes, that matches H, because H says that you have something in the first, second, and the second column, but nothing in the third. So this is good. This is in H. We're good. All right, last thing, if you take C times U, is that also in H? Well, that's going to be C times S, C times T, and 0. Yes, that is in H. Perfect, perfect, perfect. All right, one more example for us, bringing back in vector spaces. So if I know that V includes two vectors, V1, V2, and H is the span. Let's remind ourselves what span is. Remember, span is any linear combination. So H is equal to C1, V1 plus C2, V2, right? That means that that's what the span is. Well, then if C1, let's do number 1. Oh, show that H is the subspace. Okay, perfect. So if we have 0, V1 plus 0, V2, that's in the span, 0 vector in H, beautiful. All right, number 2, let's set up 2 new vectors. Let's let U equal C1, V1, C2, V2, and let's let W equal, C3. It doesn't really matter what we call this, X1 plus C4, X2, okay? If I add these together, we end up getting, this needs to actually be the same vector. Sorry about that, because it needs to be V1, V2 in our vector field, so those need to be the same. It's just that their constants can be different. But if I add these together, right, then I have a constant C1 plus C3 in front of V1. I have a constant C2 plus C4 in front of V2. That's still in H, like it still models that same format is what we're looking for. And then same thing, if I take some letter, let's just say like A times U, then A C1, V1 plus A C2, V2, that models the same format. So yes, H is a vector space, which it says show that it is. So I knew it had to be, but it's just like going through those rules, those 3 steps, those 3 properties to make sure that you can verify what a subspace is of a vector space.